So, in the previous few videos, we have talked about some of the basics about uh, the branching structure, and also we started to talk about the loops, right? We looked at one example of the for loop, and we used the for loop to solve the Fibonacci sequence problem. Um, in this video, we're gonna sort of start to work on somehow a more realistic problem. Fibonacci sequence is like a more kind of a theoretical or mathematical problem. But in this example, we're gonna sort of look at a more realistic example or more practically relevant example, and see how we can actually write a matlab program to solve a practical problem. So the problem is like this. It's called the total interest of a loan. Right? So if we borrow money, for example, we take out a mortgage from a bank to buy a house or something, and then we have to pay back interest. So the interest is just like the price that we have to pay for the money that we borrowed. So basically, we are paying back not just the principal. The principal is basically the money that we have borrowed in order to buy that house, right? We also have to pay back the bank the total amount of interest. And depending upon the duration of the loan and also the interest rate, the total amount of interest we are paying back to the bank can be very different. Right? And again, this is an example taken from our textbook. It's example 4.7, right? And that's our textbook. Right? So how do we actually quantify this kind of problem, right? We have a description of the problem, and then we have a bunch of mathematical equations that allows us to actually describe the problem in a quantitative way, right? So let's just read through it. We shall compute the total interest on a loan when the amount of the loan is L. So we are borrowing this amount from the bank, and the amount is denoted as capital L. That's the loan amount, right? And its duration is m months. So we are borrowing this much money for m months in total, right? That's the duration of the loan. So basically, after the end of this m months, we must have paid back the money that we have borrowed from the bank. That's L, right? This amount, and not just the L, right? We have by the end of the m months, we have to pay back not just the L, but also include all the interest, right? And the interest rate, it's annual percentage interest, or API, right? When the banks try to advertise their loan packages or mortgage packages, they tell you API, right? API is annual percentage interest, or annual percentage rate. Sometimes they call it annual percentage rate, or APR, not API, APR, that kind of thing. And it's called I capital A. Right? We have to pay attention. It's an annual interest rate, right? But when you actually pay back the loan, you're paying back every month, right? So this annual interest rate is not the same thing as the interest rate for every month when you actually pay your mortgage, right? So and in addition to that, it's a percentage interest rate, right? So IA is already multiplied by like 100. So if the bank advertised their APR as, say, 8, which means what? Which means 8%. It gives you one number, that's 8, right? Or 8 point something, or 4 point something, 4.2 or 4.1, right? I have no idea what's actually the average API these days. But suppose it's like close to 5, 4.8 or something, right? You get a one number, right? But that number is first of all, it's an annual interest rate, right? So it's not a monthly interest rate. A second thing is that it's a percentage interest rate. right? So if you get the number 4.8, it actually means it's a 0.048, right? You have to sort of divide by like 100. So that's IA. That's IA. And then based upon those three numbers, AO, M, and IA, you can compute the monthly payment. That's called P month, PMON, right? PMON. And there's a formula for doing that. There's an equation for doing that. So P month, that's the monthly payment. That's how much money you have to pay the bank every month, right? Equals to what? Equal to small I times the loan amount. That's the principal that you are borrowing. Divided by 1 subtract this whole thing, 1 plus small I, raised by m minus m's power, right? What exactly is small I? Small I is capital IA divided by 1200. But why you have to divide by 1200, right? That's exactly what I was just saying. It's a first of all, it's a percentage interest rate. So in order to actually get the floating point number, to actually get the real the number that I can use for calculation, you have to divide by 100 first, right? And the second thing is that it's an annual rate. So every year has like 12 months, right? So the month so in order to compute the monthly payment, you need the monthly rate basically, right? So you have to divide by 12. Right? So you take the advertised rate divided by 1200, you get the small I. That's sort of the monthly interest rate, right? Without any kind of a percentage, without doing any kind of a percentage thing, right? It's just a floating point number I. That's the number that you can use for computing the monthly payment. Right? That's sort of the equation for computing the monthly payment. So small I is the monthly interest rate. First of all, it's monthly, it's not annual, right? And then it's an interest rate expressed as a decimal number. It's not a percentage rate anymore. So each month, as the loan is being paid off, a portion of the payment is used to pay the interest. Which means what? Which means this amount of money that you pay back to the bank every month, only a portion of it, only a portion of P month goes to the principal, and another portion, the rest of it, actually goes to the interest. So for every P month, part of it goes to the interest, and part of it goes to the principal, the capital AO, right? So it's not like the money that you pay back to the bank every month, the entirety of that payment P month actually goes to pay the principal, right? Some portion of it goes to the principal. That's the money that you borrowed, and a significant portion actually goes to pay the interest. Because the amount of interest is actually computed every month, right? You got an interest rate, right? That's a monthly interest rate. So every month, the interest the interest that you have to pay back to the bank is actually the remaining balance of your principal. Multiply this rate, right? So every month you have to sort of spend some money to actually pay down the interest also, right? And so it will become more and more clear when I actually explain all the equations, when I explain the rest of the equations, right? So it's saying that each month as the loan is being paid off, a portion of the payment is used to pay the interest, and the remainder is applied to the unpaid loan amount. The unpaid loan amount after each payment is called the balance. And mathematically, we express these relations as follows. So so B0 equals to, so the balance before the first month's payment, before the first monthly payment, is going to be L. That's the amount of money that you have borrowed, right? And then the interest that you have to pay back every month equals to the balance from the previous month times the monthly interest rate, right? That's IN. That's your monthly interest payment. That's your monthly interest payment, right? And then your monthly payment, the total amount of monthly payment is fixed by this particular equation, right? And then out of this fixed amount of monthly payment, IN is the interest payment. You subtract that interest payment, and the remaining part, that's PN, is your monthly payment towards your principal, right? So the balance by the end of the nth month is going to be equal to the balance from the previous month subtract the payment that you made to the principal at the nth month, right? So IN is the portion of P month that goes toward the payment of the interest, and capital PN is the portion of the payment that goes toward the reduction of the balance, BN. That is the amount required to pay off the loan. And then the total interest paid at the end of the loan's duration is going to be just the summation of all the i's, of small INs, basically. Just to do a summation over from 1 to like m, right? And that's the problem. So how are we going to solve this problem? By writing a matlab program. So if you are a new programmer, when you actually see this kind of a problem description, it might be overwhelming. It's a really complicated problem, right? And in order to actually convert it into a matlab program, it takes some kind of a practice, right? It's not really that. Once you understand the problem, it becomes relatively straightforward. But to map the description of such a realistic problem into a bunch of codes, many lines of code, that takes some practice and also some kind of thinking, right? So how do we actually think about what's actually the correct way of thinking about solving these kind of problems, using computer programs, right? Usually, when we try to solve a problem, we try to identify the kind of data that's used in this problem, right? Let's think about data. What's going to be the data, right? What's going to be the data? First of all, we're going to need a container for storing the loan. What's going to be the loan amount, which is just basically a number, right? And then we're going to need a number or container to store the duration of the loan. That's the month. And then we will need a number or container to store the annual percentage interest rate, right? That's 3 containers for numbers, right? Or just scalars, right? And then from those numbers, we can compute the monthly interest rate, small I. That's another number, right? It's just a scalar. And then from small I and capital L and also M, we can compute the monthly payment. We can compute the monthly payment. That's a fixed number. That's another number, right? Right. So by just looking at the front part of this problem description, we need at least like a 1, 2, 3, 4, 5 containers. 5 containers for numbers, basically, right? So let's go back to MATLAB and let's try to sort of build this program one step at a time, right? A little bit at a time. So let's go back to MATLAB. So again, I have to sort of rearrange the windows so I can see the problem. Let's create a script. Let's just do a new script, right? Before we actually create a function, let's just write a script first. We need like 5 containers, and 3 of those containers, for example, the loan amount, the amount of loan, the duration, and the annual percentage interest, those can be gathered from the user, right? Let's just call it L, capital L equals to input. Now, before we actually write the code, let's write a comment. Compute the total interest of a loan, right? And maybe let's just save it. Total interest of loan. Let's just save it like that. And then capital L That's the long amount, right? Equal to input. We're gonna gather it from the user. Please enter the amount of the loan. Right. And in, we're gonna need a variable to store the number of months for the duration of the loan. Right. M is gonna equal to input. Please enter the duration of the loan in months. How many months, basically. Right. And then its annual percentage interest, IA. IA is going to equal to input. Please enter the annual percentage interest. Right, that's 3 inputs that we can gather from the user. Right, and then from these 3 inputs, we can compute the small I first. Right, small I. But don't forget, small I is sometimes used to represent the imaginary unit for complex numbers inside of a matlab. So it might be better to use a different name, right, to store the monthly interest rate. Let's just call it IM. Maybe let's just call it monthly interest rate equals to. Oh, it looks like it's kind of a very long name. Right? It's very descriptive, but it's kind of too long. What might be a good thing to try? Let's just use IA. Right? IMON or something like that. Monthly interest. Right? Monthly interest IA divided by 1200. Right? And then we can compute the P months. Right? P month. That's gonna be I month times capital L, and then divide 1 subtract 1 plus I month, right? And then just raise it by a certain amount of power. That's minus m, right? And yeah, and that's the whole thing, right? That's the monthly payment. Let's just give it a try. For this part of the code, let's see if we got the monthly payment correct, right? Let's see if it's gonna be a reasonable number. Suppose we give it like 100,000. Right, that's the amount of the loan. We are borrowing 100,000 from the bank. The duration of the loan, let's give it like 30 years. 30 years, and then 12 months per year. How many months? That's 360, right? Yeah, 360. Right. And then enter the annual percentage interest. Say 8%, right? That's a kind of high number. And then what's gonna be P month? The monthly payment, $734, right? Looks like it's not a huge amount. It's not a huge amount. Seems to be reasonable. Right? So that's the 5 containers. That's the 5 containers, right? So we have actually solved, described, not exactly solved. We have actually described as the front part of this problem, right? The beginning part of the program. At least we now have an estimate of the monthly payment, right? If our calculation is right. So then what's gonna be the next step, right? What's gonna be the next step? The next step is gonna be iterative. It's gonna be iterative, right? So it's gonna be iterative because of those equations here, right? if you have looked at the Fibonacci sequence now, description problem description, this kind of iterative thing is given by the indexes. If you pay attention to the index, right, the interest payment for the nth month equals to the interest rate small I times the balance from the previous month and subtract 1, right? So every time that you see this kind of a dependence on some values that's computed in the previous iteration, then it's a iterative problem, and we have to solve it by using. Usually, we have to solve it by using loops, right? We usually have to solve it by using loops, right? So when we have to actually solve this problem by using loops, then the first thing we have to sort of think about is how many iterations we have to sort of carry out, right? How many iterations? So for this particular problem, the number of iterations seems to be quite obvious, right? It's just the number of months, the total number of months, which is m, right? You pretty much just have to actually iterate like m times, this many times, right? So in order to actually carry out this loop, we will need to actually iterate by this many months, right? So suppose we want to write the loop, then what's going to be the index for the loop, the counter for the number of loops, right? Let's just use n as our counter. So n has to go from, so if we look at the mathematical expression, the balance at the 0th month equals to capital L, right? But MATLAB doesn't allow a 0 index in the arrays, right? So the smallest index must be 1, right? Must be 1. So if we want to use n to index into those arrays, right? So I, P, B, this kind of, if we actually want to use arrays to represent those things, right? And using n to index into it, then we're gonna have trouble, right? Then we're gonna have trouble if we start n with 1, right? So if n starts with 1, 1 subtract 1, that's 0. B0 is fine with math, but it's not fine with MATLAB, right? There's no 0 index in MATLAB, so the smallest index has to be 1, right? So what we have to do is actually start n with what? Start n with 2, so that B1 actually is capital L. It's not B0, right? So n has to go from 2 to what? What we are saying is that we need a duration of m months, right? So if I just n at m, then the arrays are not going to actually reach m, right? So so what you have to do is to, for example, the balance, right? It's going to be m subtract 1 for the last iteration, right? You haven't actually got the entirety of the duration yet, right? So the range of m, so the range of the iteration has to go from 2 to m plus 1, and that's gonna give you m iterations if you count it, right? Suppose m equals to 10, 10 plus 1, that's 11, right? From 2 to 11, that's how 2 to 11, that's how many numbers? That's exactly 10 numbers, right? That's exactly 10 numbers. So if you fix the range from 2 to m plus 1, then you're gonna do exactly this many iterations, this many iterations, right? So once we have fixed sort of the range of the iterations, right? So from 2 to m plus 1, then now let's think about what's gonna be the data. What's gonna be the data that we can use in order to actually solve the problem, right? Solve the problem inside of the loop, basically. So if we could look at all the mathematical symbols with the subscript, it's just a 3. It's just a 3. I am capital Pn and then small bn, right? it pretty much just involves these three numbers, these three sort of quantities, right? And then every time we see a mathematical symbol with some kind of subscript, we can think about arrays, right? So in mathematical representations, subscript is used to indicate the kind of ID inside of a particular array, right? And in MATLAB, this kind of subscript usually translates into parentheses, right? You use the index inside of parentheses to retrieve a number from an array. So now let's try to define three arrays, basically. Let's define three arrays. So the first array that we're gonna define is probably B. That's the balance, right? That's the balance. So B equals 2. So what's gonna be? Let's try to construct an empty array with initialized to zeros, right? And the MATLAB function for creating this kind of array is called zeros. And then you have to sort of specify the dimension of the array. What's actually the size of it, right? And use that dimension as the kind of input to the zeros, right? We used the zeros function in the previous video, but now let's use it again. So B, what's going to be the dimension, right? It's going to be a one-dimensional array. It's not two-dimensional. It's a one-dimensional array, right? So you can think of it as some kind of vector. So if it's a vector, then you can choose either it's a row vector or column vector. It doesn't really matter for this particular application. You can use either one, right? In the previous video, we were using row vectors, but this time let's use column vectors, right? Column vectors means that the second dimension has to be 1, right? And then the first dimension is the row number. How many rows we're gonna use, right? If you account for B0, right, and then n months of duration, right, then the total number of elements inside of the B array is n plus 1 actually, right? If you start counting from month 1 to month m, that's n months, right? But if you're starting to count from month 0 to month m, that's n plus 1 elements. So n plus 1, that's gonna be the total number of rows, right? So this B is gonna be used to store the principles, all the principles, right? And then let's just follow the mathematical expressions here. The next one we can compute from B is I, right? But again, we probably don't want to use I. Let's use I. Maybe not I. Let's just call it int. Int, is that a function? I think it's a MATLAB function. The MATLAB actually has a function that's called int. Yeah, it has a function called int. So it's probably a bad name to use int. It's called interest. Int month or something, right? Monthly, right? So int monthly, because int monthly, the interest that you have to pay every month is computed from B, right? Let's just initialize it to B, to all the values that's inside of a B already, right? This is sort of similar to B is initialized to all zeros, right? You're basically assigning all those zeros to int monthly, basically, right? So this line is sort of equivalent to zeros, n plus 1, right? But it involves less typing. It involves less typing if you just use the B that you have already initialized. And then principal Pn, let's just call it capital P, right? P, let's also initialize it to the same value as B. And that's pretty much the three arrays, right? That's the three arrays. But again, this is like a kind of long. Maybe let's just call it ints or something. Right, ints. And that's all the kind of arrays we're gonna need in order to actually use them inside of this kind of iteration, right? And then we have to sort of specify that B0 equals to AO. Right? B0 equals to AO means what? Means B1 actually equals to what? AO. Right? So we are actually using the first element inside of this vector to store the balance of the zeros month. That's capital AO. Right? And then what's going to be IN, right? IN. Oh, not IN. It's a ints in, right? Then we can just use the mathematical formula here, right? It must equal to small I is what? Small I is I mon that we have sort of translated into this code here. It's I mon times the balance from the previous month. That's B, and subtract 1. Right? So for the first iteration, when n actually equals to 2, so int 2 actually means the first month. It's not really means the second month, right? Because the first index 1 is used to refer to the zeroth month, right? So when n equals to 2, which actually means the first month, so ints in the first month, interest you have to pay is I mon times B when n equals to 2. 2 subtract 1 is 1. It's B1. B1 is B0, which has a value of capital AO, right? So that seems to be okay. And then PN is what? PN is the amount of money that you pay towards the principal every month, right? So ints N is the amount of money that you pay towards the interest every month, right? So it's just a Pmon subtract ints N, right? That's the amount of money you pay towards the interest, right? Because every month you are paying Pmon this much money in total, and this much actually goes into the interest. So the amount of money that goes into the principal is only this thing subtract this thing, right? And then once we got Pn, we can update our B, our balance. That's Bn, right? Bn is gonna equal to B and subtract 1, subtract Pn, right? And that's sort of the body of the for loop. And we're done with the loop, basically, right? And after the loop completes, we should have these 3 arrays that's populated with the correct numbers, right? And then the total amount of interest, is just a summation of the interest that you are paying every month through all the months. So in this case, let's just call it total interest. Total ints equals to, and matlab provides an intrinsic function for summing over all the numbers inside of an array. So sum ints, that's our total interest. And then we may want to display the disp total interest of the loan. And then num to str total ints, right? And then we have to sort of concatenate the whole thing inside of a the whole string inside of a square bracket, and then that's used for the input to the disp function, right? And now we can just run this code and see what's going to happen, right? The amount of the loan still 100,000, and then duration 360, right? The annual percentage rate 8. So the total interest of the loan, it's this much, right? So does it look reasonable? Yeah, I think it looks like there's no unreasonable values, basically, at least, right? looks like it's a reasonable thing, right? But the thing is that we are borrowing 100,000, but the interest, the total interest, the total ins is how much? It's actually more. It's actually more than the principal amount of the loan, right? So one of the things that we might want to do is to actually display this result in a graphical way, right? Suppose we can let's think about what might be a good graphical presentation of this kind of calculation results, right? So one of the things that people often do is to actually plot pie charts, and MATLAB actually provides this kind of function called pi. If you haven't used this pi function before, you can type help pi, right? Help pi. So it's gonna plot a pie chart. So pi x draws a pie plot of the data. So what's gonna be the input to this particular pi function, right? The values in the x are normalized via x divided by sum x, right? So basically, if you don't do any kind of configuration, it's gonna just take a kind of a matrix, some kind of thing, or vector, right? Vector sum x is gonna give you the summation of the total amount inside of that x vector, and then it's gonna for each element inside of the vector, it's gonna x vector, it's gonna draw the proportion of it. So let's just give it a try. Right. Suppose we already have those values in our workspace. Let's just experiment with it. Let's create a figure first. Right, that's gonna be our figure. It might be a good idea to dock it. So if you want to dock the figure, there was a sort of kind of small arrow. Dock the figure, and then we can just pi, and then what's gonna be the vector that goes into it? That's we're gonna plot AO. That's the principal, right? That's the amount of money we borrowed from the bank. And then what's the second number? That's the total interest. Ins, right? And then let's make a plot and see what this thing is gonna look like. Okay, so it looks like 38% actually goes into the principal, right? 62% actually pays for the interest, right? So if you want to sort of look at the kind of distribution of your monthly payment, right? The monthly payment, again, let's dock the figure. We have a small arrow here, right? So for every month, let's go back to the code. So for every month, you're paying P amount, right? That's a fixed amount, right? That's a fixed amount. Okay. But only a portion of it goes to the principal, and another portion actually goes to the interest, right? So you have two arrays. One is Pn, that's the amount that goes to the principal, and then int n, that's the amount that goes to the interest, right? And suppose we want to sort of visualize both of them at the same time, right? And MATLAB, usually people actually visualize this kind of a thing using bar charts. And MATLAB also provides a function called bar. If you haven't used it, because you can use bar here, help bar. Then it's going to tell you how to actually make a plot of it, right? So it takes two inputs, x and y, right? And then you have some other configuration parameters, for example, the width of the bar, that kind of thing, right? And then you have grouped and stacked, right? So what we are trying to visualize is basically the amount of money pays to the principal and the amount of money pays to the interest for every month, right? So maybe a good choice is to sort of visualize both of them in a stacked way. So the interest is like on top of the principal, right? And let's experiment with it. So the horizontal axis is going to be x, right? X is what? X is 0 to M, right? That's the total month, total number of months. And then y is going to be what? Y is actually two vectors. P, that's the principal, right? But it's a column vector. It's a column vector. Right? And then ints is another column vector, right? So we want to sort of put these two column vectors into like a larger matrix, right? How do we actually concatenate them? So P is a column vector, so it becomes one column in this larger matrix, right? That's the first column. And then int C is going to be the second column, right? And then how these columns are kind of concatenated, you use a comma, right? You use a comma to concatenate two column vectors into like a one larger matrix, right? So this larger matrix that's constructed by using this kind of square bracket operator is going to be two rows and n plus 1 rows, two columns, n plus 1 rows, right? N plus 1 rows, two columns. And then let's give the width of the bars are going to be 1. Means what? Means that the bars are going to fill up the gaps between all the bars. So there's no gaps between bars. We're going to make this kind of plot in a continuous way, basically. And then stacked. Stacked means the interest are going to be plotted on top of the principal for every month, right? Let's look at what's going to be the effect, right? Right. 360. So the yellow part is actually the interest you are paying for every month, and then the blue part is the amount of money you are paying towards the principal. And you can sort of see at the beginning, when you just started to borrow the money, paying back the money, probably the majority of the monthly payment actually goes into the interest. Only a very small portion actually goes into the principal. Right? And as time goes by, more and more of your monthly payment actually goes into the principal, right? And by the last month, the amount of money paid to the interest is almost negligible. And another thing that you have to sort of pay attention to is that the total amount you are paying is always about 730 something, right? So the entire height of the stacked columns is about constant. It's constant, right? If you want to make the plot tighter, then it's gonna look like that. It goes up exactly to like 360 or something, right? So what's actually the total amount of money you're actually paying back to the bank, right? If you just add up all the numbers in the blue zone, that should be about 100,000. If you just sum P, that's exactly 100,000, right? That's the principal, right? But if you actually sum up, it's P mon, right? P mon. If you actually do a multiply 360, that's actually a lot higher than the principal, right? That's actually a lot higher than the principal. The principal is just 100,000, but the amount of money that you're actually paying back to the bank, including all the interests, is actually how much? It's 264,000, right? It's a lot higher. It's actually a lot higher than the amount of money that you are borrowing from the bank, right? So the bank actually makes money this way, and it makes a huge profit this way, right? So if you think about it, how do you actually sort of reduce the amount of money that you are paying back, right? How do you actually reduce it? The correct way of reducing it is actually try to pay some extra to the principal, especially at the beginning of the loan, right? So your monthly payment is like fixed by that formula, right? But if you actually spend some extra money at the beginning of the loan to pay down the principal, then the interest will reduce actually quite significantly, right? But that's not really exactly a problem with programming. It's a problem with finance, right? So now let's we have experimented with both the pie chart and also the bar chart. And then let's try to build it into our script, right? So we're gonna create a first figure, right? Figure 1, right? And then we're just gonna repeat the pi command, right? Pi L total ints, right? And then another thing that we might want to do is to create another figure. Let's call it figure 2, and then use the bar, right? Use the bar that goes from 0 to m. 0 to m. That's our horizontal axis, and then the vertical axis is p concatenated with ints, right? And then the width is 1, and then the style is stacked, right? MATLAB is actually telling me it's unnecessary to actually group it with square bracket, right? Okay, so that's our complete script. That's our complete script, right? And then the next step is probably try to actually encapsulate the entire logic into a separate function, right? So we're gonna basically let's first create a function. Let's function. So let's just call it total interest. Interest of long. Right. Input arguments is going to be 3 numbers, right? The principal that you are borrowing, the duration, and then the duration in terms of months, and then the interest rate APR. It's IA, right? And then the output is going to be the total interest. Right. And then total interest, right? Total interest. Or total ints. Just make it consistent. And then all we have to do is to actually cut the codes that's starting from the calculation of the monthly interest rate towards right, that's towards the calculation of the ints. Control X to cut it, and then paste it back. Right. And then save this particular function. So the function happened to have the same name as the script. So maybe it's a good idea to actually change it to a different name. Total interest of loan calc. Right, calculation. Yeah, save it. And then back in the total interest of loan script, we can call that function, right? So total ints is going to equal to total interest of loan calc LMIA. And before the calculation, let's clear all and then close all. Yeah, I think we're pretty much done here. Let's just run it. The total the amount of the loan is gonna be 100,000. Right. Please enter the duration of the loan in months 360. And then enter the annual, let's give it 8, right? Oh, I see. The reason that it's reporting error is because it's not, the function is not really returning the principal for every month and the interest for every month. Right? It just returns the total interest. So when the bar function tries to actually make a plot of those things, it doesn't know where the p and ints is actually coming from. So in order to for the whole thing to work, you have to return more than just the total interest, this particular number. You have to return more from this particular function, right? So basically, we have to also return p and ints, right? Right. We have to return p and ints. save it. So now when we call the function, we have to sort of give it, assign it to more than one output, right? Total ints, that's fine, and then p, that's the principal you pay back, ints, right? And now it should work. 100,000, 360, and then 8. Okay, so now it looks like it's correct. Missing one figure. Oh, one figure is here. Right? It might be better to just use subplots. So you have just one figure to manage. One row, 2 columns into the first one. And then subplot. One row, 2 columns in the second one. Right? And then let's add an access type to make the access tighter. Right. Let's run it again. And then 360. Right. Right. So that's our solution for the total interest of a long probe.